before. So now we will see another trend in industry and network virtualization is the concept of network function virtualization. But before detailing the principle of network function virtualization, as asked by Esma, I will give you some overview about different definition of the cloud and how it's organized now, the cloud, before entering in the concept of network function virtualization. So I assume that all of major part of you are aware about cloud computing. So cloud computing is, everybody's talking about it. It's a buzzword. So now we see cloud computing in every area. Now we are talking about cloud computing, fog computing, cloudlet, and so on. So it's mentioned as one of the top 5 technology trends in the future. So clearly in 2020, the market of cloud computing will grow in a more exponential way. So let's see some definition on cloud computing. Cloud computing usually is now about the term of CRUD. CRUD means create, read, update, and delete resource on demand, any scale, which means elastic scales, which means that if I want to create a virtual machine, I do it in a very easy way. So CRUD request realization within few seconds to minute, which means that we can create resource in few seconds and a minute. We can ask for any type of resource, so physical, server, storage, network device, but also virtual machine, VLAN, bandwidth, software, and so on. So if we take a look to the cloud computing, we have several actors. We have tenant, what we call tenant, which means the person which are connected to service in the cloud. It could be an enterprise asking for resource. It could be a person using a software as a service, like Google Doc and so on. So this tenant is connected to what we call cloud framework through a high-level API and is accessing this resource as we have as a scale, computing, storage, and network. In this industry, we have what we call the cloud service provider. So you may know that there are a lot of cloud now provider at the large scale. You know, Google is one of the cloud provider. There is Amazon, and we have also Microsoft Azure, and so on. So the cloud service tip we found, as you may know, there are 3 main cloud service organized service tip. So we have what we call the infrastructure as a service, which concern more about network architect. So an enterprise wants to create a network, and this network is composed by a certain number of machines and connected together to create this virtual network to do some task. So I show you in the precedent presentation how we can with Nicira create such of network by using SDN and OpenVSwitch. Another one is platform as a service. So it's more dedicated to application developer. So it concerns how creating a service on the platform. And we have software as a service. I assume that most of you have an experience with this, with Google Doc and Dropbox and so on. Let's see the first one. The first one is, as I said, infrastructure as a service. So in this one, we are asking for logical or physical resource, and this typically bar-bound virtualized resource, which means that we need to create some resource, we need some computation resource, like virtual machine, some storage by using storage unit, Here in the storage, we are not talking about megabyte or kilobyte and so on. We are talking about objects. So most of the cloud framework are using object. For instance, we are using Microsoft is the storage is based on blob, and Google is using bucket. Also, we are about creating network, virtual network element. We are creating bandwidth, firewall, and so on, and all will be on the cloud. Many cloud service providers have proposed such system like infrastructure as a service. We have Amazon EC2, Rackspace, and one of the famous open source cloud framework in this case is OpenStack. So OpenStack facilitate the deployment of infrastructure service. We can create an infrastructure, for instance, to implement some caching functionality, some system management, and so on. So if you have any question on this, maybe we can be more interactive. If you have any question, you can ask it, and I will reply to it. The other tip is platform as a service, and here is we are more dedicated to, as I said before, to application developer, where here we need some application server in order to implement and develop application and put the application in this platform. Most known platform, for instance, to develop is Apache Tomcat, which is open source, and IBM WebSphere. So user upload code, which is executed on application server. So this kind of platform as a service is generally used. For instance, there are some research laboratory which need a lot of computing to do simulation, physical simulation on a big simulation. So they ask for this such of system in order to execute the simulation and having a resource on it. So the underlying infrastructure resource, which means all about all the affectation of resource to this application, VM, load balancer, storage, are acquired by the platform as a service system as needed, which means that the user does not ask for instance, creating this resource, I need more resource. So the user just asks, I need some number of CPU, I need some platform, and the system is taking over and create all this, and the user is completely not aware about this. Not like the infrastructure system where the user requests what he needs. So some what we call cloud server provider here. We have one of the biggest one is Microsoft Azure platform as a service. We have Google App Engine. We have VMware. All big names are in this kind of infrastructure. The third one is software as a service, which is more dedicated to people everybody is using it. So it's more full finished application product which are using this software as a service. So we are asking for software. So developer can customize application by using the SDK proposed by the provider. So here this is the three type of cloud usually known, but now with NFV we see there are another trend for this X as a service. Now we have infrastructure, platform as a service, and software as a service. You will see later we can have more about network as a service, CDN as a service, mobile network as a service, and so on. So also in the cloud deployment model, we have two deployment models. We have the public one. In the public deployment model, we have a tenant, which is a user or enterprise, who is connected to the framework, cloud framework, and this cloud framework has to handle multi-tenant, and this framework is public. So here you have the definition of NIST, but I will not go through until line. But the cloud infrastructure provisioned for open use by the general public, meaning that everybody can subscribe to this public cloud. tenant cloud, which means that we have multi-user using this cloud public. Of course, there is the private cloud, which is more hosted by enterprise. This one is when an enterprise use a data center, and this data center is handled locally, which is private. It means there are some enterprise now investing on data center. There is network operator having data center, which is used only for their task, not for providing to public. This is the main private and public cloud used. Market, there is some hybrid. I will not enter in the detail. So if we take the picture in 2013 about the deployment of a cloud, we see most of, as it's obvious and clearly, most of the deployment concerns software as service. So about all this kind. We have a platform and service which is more newer for user with Microsoft, and after that we have an infrastructure with player like Amazon, Verizon in US, and we have private private cloud. This, as I said, is more dedicated to the enterprise and private use of the enterprise. As the telecom system, we are using this for the private network. Usually, a cloud platform is organized as this picture, practically almost as this picture is defined. You have the tenant, the person who is connected to the cloud, is using some interface, which means some API, and the cloud framework system, which was detailed here in this picture, it must have, as you say, it looks like what we saw before with the controller in SDN, which means he had to manage the through the low-level API, the computing, have to interface the computer system of VM. He had to also some interface to manage the network. Here we are talking about SDN. And at the top layer is a cloud controller that interface with the tenant. So much of here this functionality are available in the OpenStack and Cloud Stack and so on. So a tenant generally use an API and get mapped to relevant cloud resource and the so famous CRUD, which means that according to the API here, he can create, he can release, he can update, and he can delete a resource. So for instance, the CRUD API get mapped here, for instance, for this VM interface could be the KVM management, KVM hypervisor, or Xen hypervisor, which is interfaced with OpenStack in order to do this stuff. So it provides some cloud abstraction to the tenant. So the tenant facing here generally is based on REST API, like the example I show in the northbound for SDN. In order to request this resource, in order to create, to manage this resource, so the VM interface is based on the famous libVRT, which is available in KVM. I don't know if you are familiar with such kind of hypervisor. It's an open source hypervisor, and it allows to manage, to create a VM, to delete a VM, and to migrate a VM from one data center to another data center, and so on. Also, there is, I think you are aware, you know VMware. So VMware is doing the same thing that by using Hyper-V, but the Hyper-V API in VMware is an industrial project that, unlike the KVM, which is open source. So KVM is open source, we can use it, you can use it for managing VM. A network interface could be OpenFlow, Open vSwitch, Linux, Bridge, and so on here to manage this virtual network resource. So for instance, here an example of a REST API to create, for instance, a virtual machine. So here, the creation of virtual machine, remember the post. post requested, the HTTP request, I show you the example for when we use it with Abdeljelil. Here we can create as a new machine server, and we give the name of this machine. This machine, for instance, could be CDN Line 1. And we have the reference image of this operating system. Because a VM is only operating system. So imagine as its name indicate here, a CDN Line 1 could be a system of caching, could be a VM machine installing a proxy server like Squid or Nginx to do caching. So the cloud, the OpenStack here will create this machine, and which is according to the REST API provided in this URL. Another example here, for instance, to reboot a machine. You want to reboot a machine from the OpenStack API. For instance, you can use this post and asking an action, and here the JSON representation of reboot type hard because we need to reboot the machine. So all this is controlled by high-level API. Of course, as Abdeljelil, OpenStack provide this interface in order to control the system. So it's more user-friendly. So if you are not aware with REST API and JSON, you can use this one in order to create VM, to delete VM, to request VM, to create a new image, and so on. This interface is a user guide. You can use it by implementing the system. Here also we have a vision of the system in the browser directly. So you can, according to this, you have, for instance, information about the virtual machine, how you can, the reference of the machine, how where to find it, and so on. So the advantage of the cloud is it allow scaling, create, delete, resource elastically, which means that we can do whatever we want with a machine. It's just a software resource. So we can create it, delete it, whatever we want in an elastic way. So sometimes when the resources are needed, it's possible to scale up by acquiring more powerful computing, storage, network element. For instance, this could be interesting when we will do network function virtualization. Imagine that you have a server, web server, on the software, hosted in the cloud. Imagine that the content will be, for some instance, popular. So we can create a new instance of the server, create a load balancer, and create a new resource which scale with the asking demand of user. So I try to do it quickly because not the aim of all the presentation. So just to show you how some example about the cloud, and you will see later how the NFV could benefit from this cloud in order to create more efficient network platform. So now let's move to the network function virtualization. So what is network function virtualization? So network function virtualization, as its name, is to build software implementation of network, which means that all the functionality we know which are hosted in hardware could be created in a software way. So we need to firstly, and after that we provide network function module and all implementation in the virtual machine. So you see the link with the cloud, because now this virtual machine will be hosted in the cloud, and all the network function will be available in the cloud, and we can create it in demand and in elastic way. So generally, if you take a look now, if we want to most of the deployment are hardware, but with the cloud, now we have a lot of resources, a lot of CPU, and now we can take advantage from this resource, from this flexibility, to create network function. So this function could be put in the cloud through only virtual appliance. So we take here advantage of the virtualization, all the term of virtualization, quick provisioning, scalability, mobility, and so on. So why NFV? why the need of NFV? Maybe this could be an answer of a precedent question. So here we can create network resource without worrying about where it's located, how much it is, how it is organized. So all the complexity will be done at the cloud. So we could do a simple orchestration function, which means orchestration means to manage the thousands of devices in a more efficient way by relying on cloud computing technology like OpenStack. So dynamic scaling, programmable in order to program the network function, visibility, performance, multi-tenancy, which means that we can have, for instance, a network operator can open his network for several tenants. For instance, most of network operator have some problem with content coming from YouTube and Dailymotion because they are consuming a lot of resource. So now, with network function virtualization, the network operator can open his network in order to host the NFV function needed to serve YouTube or Dailymotion on the network. I will show you how this could be done. And also openness, which means that now we can open the system. So when we are creating software, the system now will not be dedicated only for the well-known actor from industry like Cisco, like Juniper, but now everybody have an idea, have a way to create a software resource for a network, could do it easily and interface through API. So maybe you feel that these requirements are the same as SDN. So what are the difference between NFV and SDN? So I will come back maybe with the picture, but here's some NFV example. This NFV example is now developed, and most of industrial actors have an example of this software running on virtualized environment. So we have all the function of switching. We have the function of mobile network node. Maybe Tariq later will present more detail on the mobile world. We have home router, we have element, we have traffic analysis with deep packet inspection, which are now going to software. So deep packet analysis, which was generally based on some appliance, like, I don't know if you know Snort, but here is to go directly to software, and you will see how we can do service check, need to have it. Application level optimization, security function like firewall and so on. So the difference between NFV and SDN relationship, so NFV and SDN are complementary, which means that SDN, as you see before, is on abstracting the control plane. NFV is about how we create network function and put it as a software. In order to use SDN, in order to create this flexibility and create this instance on demand. So NFV requires moving network application from dedicated hardware to virtual container on what we call commercial off-the-shelf hardware. Which means that now we are not needing, for instance, a dedicated router, but only a CPU and only virtual machine could do the job. So here the relationship. So between the VM orchestration systems, the COTS compute evolution and SDN controller. So network function visualization will be somewhere between all these elements, which means that network function virtualization is not possible without the development of all the three together. So what are the concepts of NFV? So the NFV now is going with more architectural concept. So we have the network function. So as its name indicates, is the functional building block in order to create a network function. We have a virtualized network function, which means here is the software implementation of the network function. So now, for instance, a firewall function is known as a virtual network function. This acronym is used for architecture. We have the VNF set, which means the connectivity, one important thing is the VNF forwarding graph. For instance, when we create a VNF router to represent the routing, so we need to tell the system, the OpenStack system, the graph of creating this VNF and how to connect them in order to create a service. We have the NFV infrastructure, which contain all the hardware and software required to deploy, manage, and execute virtual network function, networking, and storage. Here's the big picture of this. So, at the low level, we have the network function infrastructure, which contain the virtual compute, the virtual storage, virtual network, over virtualization layer, which is proposed by KVM or XAMPP. We have the real compute and hardware storage, and here we have the VNF instance. These VNF instances are relying on this to provide such service. Imagine that we need to create a service that must go through this VNF before arriving to this endpoint. So the first thing is to create this instance, and after that we know we provide how to connect this instance by providing a graph, a connecting graph, and this connecting graph will provide the service. And we give this information to this infrastructure in order to create, from this logical point of view, a realization of this network, for instance, in the data centers, by using SDN, by using Open vSwitch in order to connect all the elements as I presented in the precedent presentation. So if we take a look more deeply to the network forwarding, this will help to differentiate between a flow going from one physical network to another physical network. So the network service provider will define what is his need, how we want that the flow coming from here and here will be treated. So he defined the VNF forwarding graph, and for instance, we have one flow, he must go only to the VNF-A and VNF-B. So this one, for instance, could be a flow with high quality, or so we go only through this. One flow could go to these two plus these two. These two could be, for instance, this traffic, the red traffic is coming from a network which contains some security problem, so we need to do more filtering on the traffic. So, for instance, VNF-C could do some big deep packet inspection, some intrusion detection systems to this flow, and this flow, for instance, is going to this and this, and maybe this flow need more treatment, more optimization, as for instance TCP optimization and so on. So you see now how is the flexibility of VNF. So just providing this graph and deciding which VNF have to go through which one. This is called also about service chaining. I don't know if you are a little bit familiar with mobile network. So mobile operator generally, before that the traffic enter their network or when they coming out to the network, it must go through what we call the SG line, which contain firewall, which contain intrusion detection system, which contain TCP optimization, which contain firewall, and so on. So now with the NFV, we can host all this, which was implemented in standalone server, in only one virtual systems. For instance, for this traffic, the red one, you must go through the TCP optimization, the IDS, and go out, and traffic coming from the internet must go through the DPI, the firewall, the EDS, and go in and enter the network. So now mobile operator are providing this service chaining on a virtual way. So this could be done easily, flexibility, and so on. For instance, here, if we have a lot of traffic coming and must be treated by the firewall, and if we have some problem of scalability, of performance, we need just to add another instance of this firewall. So this flexibility could be provided by NFV in more easy way. But in order to have an efficient NFV framework, so we need to ensure several parameters. You know, if we want to have coming from hardware, hardware is very efficient. When you do treatment for firewall, for instance, in hardware, we are very efficient. So now, one of the big challenges with NFV is to be as efficient like the router, the hardware implementation. So this one was one of the big issues of the performance, and also there are some portability issue, some SLA. We need some service level agreement between in order to create this NFV resiliency. One of the big issues also is efficiency, because reliability. Because when you are dealing with software, you are increasing the probability of failure. Because hardware is he's more efficient and more robust than using hardware-based software. Because when the probability of failure increases, due to the fact when we develop software, sometimes there is bugs on this software. So the system has some problem of reliability, which need to be resiliency and reliability in order to reduce the failure rate of this NFV instance by report to the hardware version. So also other information that for requirement which must be implemented. Here's some insight about the data plane performance. Because as I said, if we are dealing with the software implementation, we need to be as much as performant as the hardware. So one of the issue now is we increase the delay when the packet is going through the hypervisor, because we have some input and output, and the packet must go through the hypervisor in order to reach the network function in order to be treated and going out. So this was one of the problem before deploying the NFV. But now there are some development through what Intel called the data plane development kit, which help to optimize and accelerate small packet through performance and packet processing. Clearly, this, for instance, when we take open vSwitch case, and when you have a server with multiple CPU, so we can dedicate one CPU for one port. So this DPDK allows that one CPU will be dedicated to one switching port, so in order to help to accelerate the input and the output. So this DPDK is open source, which means so we can install it, we can use it in order to accelerate. Intel do this in order to accelerate the process of adoption of network function virtualization. One thing also about network function virtualization is that there is an ongoing standardization effort, which means that the ETSI, which is the European telecommunication standard, is trying to give some standard way to have NFV. So in this architecture here, it's a little bit complicated, but don't worry. This is dedicated in this NFV architecture. So the HC is trying to create some requirements, some directive about the infrastructure, how the infrastructure should be, and how the infrastructure must be implemented. The second one is about software architecture, how the VNF must be created, how must be developed, and the management and orchestration systems. This management and orchestration systems is needed in order to create the VNF instance in a flexible way, and defining how the infrastructure should be integrated with this VNF. So the HC is trying to give standard to this interface in order to have some standard. So I will not go deeply on this detail because it's more related to architecture, but it's interesting to know that the ETSI is working on this part, but also they have some expert group working on security, because if we have software implementation, we have bugs and we have security issue, but also about performance, about portability. So the NFV infrastructure group is about defining how the hypervisor domain have to deal with the NFV. So they are trying to give some directive about the CPU needed to run the NFV, the network interface, the accelerator, the storage, and they are also giving some recommendation about the compute domain, which hypervisor should be used, and some directive about the infrastructure domain. So this group is focusing more on the NFV infrastructure group. The NFV manual, which is more related to the management and orchestration of the VNF. Because when you create a virtual network function, you need system to monitor the state of this function. You need information how this function is working, because if you detect some anomaly, some failure problem, you need, for instance, to reboot this VNF or create a new instance and so on. So the HC is defining how this could be done in the VNF. Also, another point which is currently studied in the HC is how a function could be divided, how a function could be split in order to create a service. So, for instance, here you have several ways to create network function and deploy it over the network. So here, for instance, we can have all the functions running on the same operating system. For instance, the service chaining I showed you before, for instance, firewall, IDS, TCP optimization, could be run on the same platform. But also, it could be run on the different VM. And it could be run on different VM, on different operating system, on different hardware. So all this information are needed in order when we want to deploy a new service, a new VNF. So this question need to be detailed in the upcoming recommendation of HC. So here I will give you some example about the decomposition of the evolved packet core, which is used in the mobile network. So here, I don't know if there are two main entities in the mobile domain. You have the MME, which is the mobility management element, which is in charge of handling user mobility in the network, to know where is user connecting, where is the place of user. And there is also some gateway. We have the packet data gateway in order to connect the mobile world to the internet, and the serving gateway in order to get information. Maybe Tarek will give more detail on this. And here there is a proposition of decomposing this function into sub-function in order to implement this virtualization of network and core mobile network in the cloud. For instance, you see that the NME was divided into one block, which is the service load balancer, in order to create some service balancer between the system, which is running on dedicated virtual machine. And here we have what we call the mobility management processing function, which is a VNF running apart. So when we have to deal, we gather data from the wireless network, from the eNode B, the service load balancer send the information to this function or to this function. And these are all hosted in the cloud. So they put it on the cloud, all is hosted on the cloud. Same thing here for the gateway, which means the gateway connecting the mobile world to the internet. So this gateway is divided on two functions. The first function is the control plane, which means it's controlling the traffic where to traffic is routed, and here the user plane. So it looks like the decomposition of SDN. We have the control plane here and new data plane here. So this one is running as a virtual machine, this one is running as a virtual machine, and this one is running as virtual machine. So all the communication here is based on SDN. So this one is based on SDN. This is the usual interface used in the mobile network, and here all this information are put on the cloud. This vision is what currently is defined on one of the biggest projects on network virtualization in Europe, which is called mobile network, cloud mobile network, or mobile cloud, which define the new version of the mobile core network and how we virtualize this network and put it on the cloud. So another information that must be divided in order to create the VNF is how the VNF is instantiated. So for instance, we can create n virtual machine to serve only one service, to create one service. This allows to create high reliability, which means if one virtual machine is down, another one take over. Or we can do a load balancing. Of course, there is a solution 1-1, which means that one service is hosted in one VNF. So all this information is proposed in the HC. So currently there are a lot of NFV use cases. So we have now the service like NFV as a service, which looks like as infrastructure as a service. So you see, for instance, we can have a core mobile network as a service. So imagine you can ask to create this virtual machine and create this mobile network. We can have the service chain as a service in order to create this service chain in order to be treated by the firewall, by the BDS, and so on. And also there are a lot of use cases defined for this NFV. But now the HC is just defining the architecture and the interface in order to create this NFV. But we don't have a system like OpenStack or OpenDelight in order to handle this this NFV. So now the gap is filled recently by the launch of the Open NFV initiative. So as the Open initiative is led by big industrial, and the Open NFV scope is more at this moment related to the NFV infrastructure and rely mainly on OpenStack. So Open NFV initiative is using OpenStack in order to create this NFV system and this NFV architecture. So I will finish my presentation by showing an example at what we have, what we call a CDN as a service. So as you may know, now most of the service of the content are handled by CDN, which means that the content is not hosted at the server, but popular content are cached in the network and through using some CDN server, and we are doing some load balancing and so on. So now I will show you how we can, for instance, an operator can create a CDN as a service for a third party in very easy way by using NFV. So imagine that you have content to deploy in a certain location. For instance, some local festival or so on, and you don't have the infrastructure to create your CDN. So, but the network operator or the cloud operator has such infrastructure. This infrastructure is called what we call it the federated cloud, because now most of the provider of cloud have some federated cloud in several locations. So the content provider through an API and through OpenStack, we said, I have this video which is about this festival, and I want that this video will be will be put in the network for this location, and we want to serve this population of users. So now the system take this information, take this person, and now what the system do is just creating a virtual instance of this caching system. So by using any implementation of Squid or Nginx, and now push this content in the cloud, into the cloud, and after that the user, when he asks for this content, it could be directed to the nearest cache or nearest CDN in order to be that his request will be served from the optimal data center and the optimal instance. So, and users are directed, and the original server is not concerned about this, but now all the information could be gathered from this federated cloud. So by using any DNS or HTTP redirection, as usually is done with CDN. So now, if we take a look at the orchestration system, so how this system could be implemented, how it could be done with NFV. So we can provide some REST API for the CDN service orchestrator. So the request of the user come here. So this service orchestrator will ask the NFV orchestration systems, like defined by the EC, to deploy a new service. Imagine that you have a video, as I said, to deploy in certain location, and in order to serve a certain number of users. So you see clearly that there is some optimization algorithm needed behind. So the network orchestration take this requirement and send it to what we call the CDN as a service, which contains the descriptor of the software image, which means that the software including Squid or so on. And also the CDN as a service could implement some optimization algorithm in order to where plus to do the VM placement according to, for instance, improving the user quality of service, reducing the energy consumption, in order to address several objectives. So we have some optimization problem to do here, and after that we deploy the SIG, what we call the graph. You know, the graph I showed you before, in order to interconnect this VNF and give this information to the virtual infrastructure manager like OpenStack, which we will traduce all this information into VM, into machine. This VM as we have the image, software image in the system, and the placement of this VM in the several data center, the interconnection by using Open vSwitch, the virtual tunnel between this Open vSwitch, and using SDN, and after that, all is placed in the network. And they said here the service instance graph would be the VNF placement in the network, and this gives you an overview of how now we can use NFV, and we can use the cloud, and we can use the SDN in order to propose a new service like CDN as a service, or whatever another service in the network. So I think I finished with my presentation, so time to question. maybe I'm not sure at 100%, but Google is not providing infrastructure as a service. It's mostly Amazon who's doing this.
So Google is supporting Amazon, or
no, Amazon is completely apart. Amazon is dedicated to create this infrastructure as a service, and Google is more, the placement of Google market is more in this one. So much on platform as a service.
My second question is about I didn't figure out the real difference between NFS and SDN. As I understood, they're both given. Yes. I'll repeat the question.
Yes, please, but because I didn't understand.
I didn't figure out the real difference between the NFV and SDN.
Yeah.
As I understood, they are both trying to give a virtualization of the network. And
okay. So, indeed, SDN is not dedicated to the virtualization to the network. It covers the virtualization of the network, but it's not dedicated to only virtualize the network, because SDN, as I presented before, is more about the control plane abstraction, which means that even we are not talking about virtualization, we are talking only about management. So SDN could be used to manage hardware open flow, and we are not talking about virtualization. But SDN is also used to handle the virtualization of data plan. By virtualization of data plan is the fact that we are using switch which are more software than hardware, like Open vSwitch, which is only software and only virtual switch. In this case, we are more about virtualization. But if we take the case of NFV, NFV is about creating a software instance of a network function. Imagine, as I show you in the last example, a CDN. Usually a CDN is a server, even it's hosted in the cloud, but it's a server which is dedicated only to serve this one, and there is no flexibility. It's dedicated to do CDN and so, and there is no other function. But if we are using NFV, we can create this instance, this virtual machine at demand, and create it on the system by using the orchestration systems. Because OpenStack is helping to do this, to create this VM instance in the network, because OpenStack is an operating system which can handle data center from different locations. You can see all the data center as locally connected, but even they are completely apart. Network function is about from moving from the hardware to the software. So firewall, for instance, firewall, you found Cisco PIX, which is dedicated to firewall, doing only firewall. So rather than having this on the hardware, we can take it on the software implementation and put it in the cloud. And when we have it on the cloud, we have to deal with it, have to manage it. Even if you saw, for the example of mobile network, all the equipment are hardware also. But now we are trying to do this as a function and trying to a way to find a smart way to define the function of mobile network and put it as a software in the cloud. Maybe we can discuss later. I give you more detail. Imagine you are a user having this infrastructure dedicated to you. So, multi-tenancy, which means that we have multiple users sharing the same physical infrastructure, but in their vision, they are using only a part of this infrastructure, and they are not aware about what happened here. Imagine this one is working on this infrastructure, and he not aware about the existence of another infrastructure which is used by another tenant. This is one of the main objectives of the cloud framework abstraction that manage this instance in a completely different way, could be different way, but completely separate. So even you have this one, for instance, maybe this VM and this VM are hosted in the same machine, but are not visible on the same infrastructure. So by doing some VLAN or some tunnel or so on with SDN and Open vSwitch, in order to separate them. This is what we call multi-tenancy. Because if you take the reliability study of this, you see clearly that there are different behavior if we are studying reliability in more theoretical way. Because hardware generally is the reliability of hardware. You have some with time the hardware is degraded, but the reliability is more higher because we don't have the bugs of the software. Because when now we move to the software, we have the reliability, the problem of reliability of the hardware we are using, which is the same as the hardware, but the software, if you take the distribution of how the reliability system look like, for instance, for the hardware generally, we can model it with an exponential function. So with time, the system degrades. But in software, you don't have such kind.
And when you add the
virtualization. Sorry, let me finish. In fact, in the software, this reliability is completely different because you have some problem of reliability at the beginning if you find bugs, but you correct it. So the reliability is completely different. So the reliability here in the software is completely apart from hardware. But the problem when you are using NFV, we will face the problem of the software and the hardware. This is one of the main challenges.
But we have, in place of that, we have the redundancy, which is
Yeah. The advantage now with this, we can use the 1N format and create some good reliability. If we have a VNF which is out, we can or create a new instance or a reboot. Because generally, when we have dealing with bugs with software, one thing we do when we have bugs, reboot the machine. Not like hardware.